Hello students, so in this video we will be solving MCQs of chapter number 2, that is electrostatic potential and capacitance, right? The questions are from your NCERT textbook and they are likely to be asked in your board exam, right? They can come in your board exam. Okay, see the first one, this is your example 2.1. You have to calculate the potential at a point P due to a charge of 4 into 10 raised to minus 7 coulomb located 9 centimeter away. Okay, so basically the question says to calculate the electric potential due to a point charge. So we know that potential due to a point charge is kq by r. Electric field was kq by r square. Remember that potential is kq by r. Potential is scalar quantity, electric field was vector quantity. Fine. So we just have to substitute the values. K is 9 into 10 raised to 9 Q. So that is 4 into 10 raised to minus 7 upon R. So that is 9 into 10 raised to minus 2. So this will be 4 into 10 raised to 11 minus 7 10 raised to 4. Got it? Clear? Because potential due to a point charge is kq by r. Then the next one. Okay, next one. For a short dipole, potential due to dipole varies dash with respect to distance. Okay, so electric potential because of dipole is given by the formula kp cos theta by r square, right? So V is inversely proportional to r square and not as 1 by r, because potential is inversely proportional to r, but it is only for a point charge. Make it very clear, for a point charge potential is inversely proportional to r, but for a dipole potential is inversely proportional to r square. So this is your answer. Got it? Clear? The next one. Third one, potential due to dipole is minimum at an angle of dash. That means what should be the angle for potential to be minimum because of a dipole? So we know that potential due to dipole is kp cos theta by r square. That means potential depends on cos theta. So when theta means cos theta is minimum, potential will be minimum. Right, so cos theta will have minimum value minus 1, and it is when theta is 180 degree, because cos 180 is minus 1. So when theta is 180, cos theta will be minus 1, that will be minimum, so potential will be minimum, right? So potential will be minimum because of dipole at an angle of 180 degree. Clear? It will be 0, potential due to dipole will be 0 when theta is 90, that is along the equator, right? So electric potential due to a dipole along the equator is 0, or on the equator it will be 0. It will be minimum when theta is 180 and it will be maximum when theta is 0 along the axis. So maximum will be kp by r square, this is when theta is 0. Got it? Clear? Fine. So presently angle is 180 degree. At 180 degree potential due to dipole will be minimum. Clear? Next one. Next one. At every point on equipotential surface electric field is. So what should be the direction of electric field for every point lying on an equipotential surface? That is, it should be normal to the surface, it should be parallel to the surface, anti-parallel, or it should be at an angle of 45. So first of all, equipotential surface means equi means same, right? So surface where potential remains the same, potential remains constant, that is known as equipotential surface. For an equipotential surface, electric field will always be perpendicular to the surface, that is normal to the surface. These are the lines given in your textbook, and in the previous year this was asked as MCQ in your board exam. Clear? That means if this is your electric field, then equipotential surface will be normal to electric field. That means if your electric field is along x direction, then equipotential surface will be along y and z, right? So at each and every point on equipotential surface, electric field will be normal to equipotential surface. That means it should be at an angle of 90 degree. Clear? So normal to the surface. Got it? The next one. Okay, fifth one. Electric field is along y direction as shown in the figure. What is the potential at point A, B and C? So in the diagram it is given that in the figure, electric field is along y direction. We have to say about the potentials at point A, B and C. Okay, see, that means VA equals to VB less than VC, VA greater than VB equals to VC, VA less than VB equals to VC, or VA equals to VB greater than VC. Okay, see, one more result we are having is the relation between electric field and electric potential, that is electric field is minus of rate of change of potential or minus dV by dr, that is rate of change of potential with respect to distance, that is equals to electric field. This relation means that if you are moving in the direction of electric field, potential decreases, right? Potential decreases while moving in the direction of electric field. That means if I am going from point A to point B, right? If I am moving from point A to point B, that means I am moving in the direction of electric field, then potential will decrease, right? That is negative of rate of change of potential with respect to distance is equals to electric field. Clear? So if you are moving in the direction of electric field, potential will decrease. Okay, fine. That means presently, suppose if these three are the points, then VA greater than VC greater than VB. Got it? So in our question, electric field is along y direction. We have been told to give the relation between the potentials at point A, B and C. See, electric field is along y direction. So these 2 points A and B will act as equipotential surface, because in the previous MCQ we have seen that electric field will be perpendicular to equipotential surface, or from equipotential surface electric field will always be normal, perpendicular. So this is electric field, right? So this is perpendicular to this surface. That means this surface A and B, these 2 points, they are lying along equipotential surface. So their potentials will be equal, because potentials on equipotential surfaces are always same. So A and B will have the same potential, and now if you are moving in the direction of electric field, potential will decrease, right? So C point is along the direction of electric field. That means we need to move along the electric field to reach at point C, right? So potential will decrease at point C. That means VA equals to VB, because both of them are at same potential, but it will be greater than VC, because C point is in the direction of electric field, so potential will decrease. Clear? So this should be the correct relation, VA equals to VB and greater than VC. This. Got it? Point A and B will act as equipotential points, so their potentials will be same, right? And point C is in the direction of electric field, so whenever you are moving in the direction of electric field, potential will decrease. Clear? Next one. Sixth one. What is the work done to rotate the dipole placed in external electric field from most stable position to most unstable position? Work done to rotate the dipole which is placed in external electric field from most stable position to most unstable position. Okay. See, for a dipole, suppose dipole is placed in an external electric field. This is a dipole. Okay. And let this be the external electric field. Fine. So work done is equals to PE cos theta 1 minus cos theta 2. Work done is equals to delta U, that is PE cos theta 1 minus cos theta 2. Most stable position is when the potential energy is minimum, right? When the potential energy of the dipole is minimum, that condition represents the most stable condition, right? Now for a dipole, potential energy is given as minus PE cos theta. Got it? So when energy is minimum, stability will be maximum, and when energy is maximum, stability will be minimum. right? That means when theta is 0, that means when the dipole gets aligned along the direction of electric field, so angle will be 0. So when theta is 0, potential energy will be minimum, which is minus PE, right? And when dipole aligns in the direction opposite to electric field, that is when theta is 180 degree, potential energy will be maximum, because it is minus PE cos 180. Cos 180 is minus 1, so that is plus PE, right? So most stable position is when theta is 0, because when theta is 0, energy is minimum. That represents the most stable position. And when theta is 180 degree, energy is maximum. That represents the most unstable position. Got it? So now we have been told to calculate the work done to rotate the dipole from most stable to most unstable position. That means we have been told to calculate the work done to rotate the dipole from 0 to 180. So we'll substitute in this equation. Work done is equals to PE. Initial angle should be 0, most stable, minus most unstable, right? 180. So this is PE, 1 minus minus 1, that is 2 PE. Got it? Clear? So work required to be done to rotate the dipole from most stable to most unstable position is 2 times of PE. Done? Clear? The next one. 7th one. What is the value of dielectric strength of air? Dielectric strength means the maximum value of electric field for which air acts as insulator, or for which air can act as insulator, right? The maximum value of electric field up to which air can act as insulator, that is known as dielectric strength. And then comes dielectric breakdown. That means electric field has increased beyond its limit, and now the air will act as conductor. It will be no longer a insulator. That is known as dielectric breakdown. Dielectric strength means maximum electric field, right? So the value is to be remembered, that is 3 into 10 raised to 6 volt per meter. This is the maximum value of electric field. Up to this value, air will act as insulator. Clear? So this options are, this is the correct option, 3000 volt per mm. So that is 3 into 10 raised to 3 volt per mm, that is 10 raised to minus 3 meter. So this will be 3 into 10 raised to 6 volt per meter. So A is your correct option. Got it? Fine. Next one. Next one. A parallel plate capacitor with air between the plates has a capacitance of 8 picofarad. What will be the capacitance if the distance between the plates is reduced by half and the space between them is filled with dielectric constant 6? Okay, when a dielectric is introduced between the plates of capacitor, then capacitance increases by factor K, right? See, first when dielectric was air between the plates, right? Let the separation be D. So capacitance was given as 8. So 8 picofarad, this is equals to epsilon naught A upon D, because for a parallel plate capacitor, capacitance is given by the formula epsilon naught A upon D. Now, what will be the capacitance if distance is reduced by half and the space between them is filled with the dielectric constant 6? Okay. So now C dash is equals to K into, because capacitance increases by factor K on introducing dielectric. Okay, so K into epsilon naught A upon D by 2, because the distance is also reduced by half and the space is occupied by dielectric constant. Fine. So this will be K is given as 6 into epsilon naught A upon D into 2. So that is 12 into epsilon naught A by D. Epsilon naught A by D is given as 8. So this will be 12 into 8, that is 96 picofarad. So new capacitance will be 96 picofarad. This was your question of exercise in your textbook. Clear? Next one. 9th one. 3 capacitors of capacitance 2 picofarad, 3 picofarad and 4 picofarad are connected in parallel. What is the total capacitance of the combination? This is very easy question. So 3 capacitors are connected in parallel, right? One is of 2 picofarad, another is of 3 picofarad and 4 picofarad. So capacitors when connected in parallel will be added up directly. So C equivalent will be C1 plus C2 plus C3. Yes, right? If the capacitors are in series, then equivalent will be 1 by C1 plus 1 by C2 plus 1 by C3. Got it? Presently the capacitors are connected in parallel. So we just have to add them, 2 plus 3 plus 4. So that is 9 picofarad. This is your equivalent capacitance. If they are connected in series, then you will have 1 by 2 plus 1 by 3 plus 1 by 4, and then you have to solve it. Got it? Next one. 10th one, a 12 picofarad capacitor is connected to a 500 volt battery. How much energy is stored in a capacitor? Again, this is very easy question. A capacitor of 12 picofarad is connected to a battery of 500 volt. Okay, so C is given as 12 picofarad, V is given as 500 volt. So energy stored is half CV square. 50% of the energy is stored in the capacitor and 50% of energy is lost in the form of heat, that is in the form of I square RT. Okay, substitute the values, half into 12 into 10 raised to minus 12 into 25 into 10 raised to 4, right? Solve this. So this will be 150 into 10 raised to minus 8, or you can say 1.5 microjoule. Clear? Okay. So students, this were the MCQs of your textbook and somewhat related with your textbook, right? In the next video, we'll be solving the MCQs of the same chapter, but it will be of higher level, right? That means the questions will be more interesting and it will be more conceptual. Clear? But for board examinations, first go through this MCQs, because these MCQs are given in your textbook and most likely this MCQs will be asked in your exam. Clear? Thank you.